In this video, we're going to focus on finding the volume of prisms. So let's quickly review the definition of what a prism is, and then we'll learn about how to find the volume of them. So just to refresh your memory, a prism is when we have some two-dimensional shape, so some 2D flat shape, so for example like a triangle, and that triangle is the base of our prism, okay? So this would be called the base. That 2D shape is located at the top and at the bottom, and then if we look at all of the vertices, okay, of that triangle and we connect them to the other base, okay, it forms this three-dimensional shape called a prism, okay? So funny enough, we can actually have any shape that we want to for our base, okay? It doesn't just have to be a triangle that we're using for the base. We could be using a square or a pentagon, hexagon, rectangle, any of these shapes we could use as the base, which is just at the top and the bottom, and as long as we just connect everything down from each of the vertices, that'll form a prism, okay? So, in the last video, we looked at finding the volume of a very particular kind of prism called a cylinder. So this is just where we had the base as a circle, okay? So we just had one circle on the top. At the bottom, we connected those together, and it formed a type of prism called a cylinder, okay? In this video, we're going to be focusing on finding the volume of triangular prisms, square prisms, and rectangular prisms. We won't worry about finding the other ones; those are a little bit trickier. But for our sake, we're going to be good enough with finding just triangle, square, and rectangular prisms. How do we find the volume of each of those? So, funny enough, to find the volume of each of those three kinds of prisms, we would use the exact same formula for each of them. Okay. So, and it's the same formula that we used for the cylinder. It's just going to be the volume, so V for volume, is equal to B, so B here is going to stand for the area of the base, referring to the base here. Whatever that shape is, maybe it's a rectangle for the base, okay? So the area of that base multiplied by the height. How tall is your prism? Is it really short, or does it extend up really far? So that's going to be the general formula that we'll use. And then what we plug in for B, for the area of the base, is going to depend on what kind of base we're using. So if we're using a rectangular base or a triangular base, that's going to be different for what we're going to plug in for B. So here are the different things we'll list that we could potentially plug in for the base, okay, for B. So some of the formulas that we'll be using to plug into B for the base will be this. So the area of, because we're looking at the area of the base, the area of a rectangle or square. So what if we had a square or rectangle for the base? Well, what we would plug in is just going to be length times width, right? Like if we had a rectangle or a square, to find the area, it would just be length times width. And then if it was a triangle, remember we talked about before, we can make a triangle by just taking any rectangle or square and just dividing it in half along the diagonal. That's how we get triangles to form. So if we just take 1/2 and multiply that by length times width. And then lastly, if we were working with a cylinder like we were in the last video, we would just do pi times the radius squared. We're not going to be using this formula today because we're not focusing on cylinders, but we would use this if we had a cylinder at all. So for us, we're just going to see if it's a rectangular square or if it's a triangle. That'll tell us if we're using this part or this part that we're going to plug in for B, okay? All right, so let's go ahead and look at this very first prism here. So what shape is the base? Okay. So here would be our base right here. What shape is this? This would definitely be a square, okay? So since the length and the width of this square, this 2D flat shape at the bottom, the length and the width are the same, that means it's a square. So on all the other sides, it would be 888. All the sides are the same length, definitely a square. Okay, so if it's a square, then I'm going to plug in length times width for B. So check this out. I will write this as volume equals, excuse me, volume equals length times width. I'll put this in a box too, just to show you that we took B and we're replacing it with length times width, okay? Length times width times height, okay? And that's how we get our formula. So the formula we would be using is going to be length times width times height. So for this particular problem, that's super easy. All we're doing is just taking all three of those numbers, the length, the width, and the height, and we just multiply all three of those numbers together. So super straightforward for a square. So whatever 8 times 8 times 8 is, so let's see, it's going to be 512 inches cubed. Okay, remember we put this little 3 here because we have 3 dimensions, length, width, and height, and we want to show that we're working with a 3-dimensional shape. Okay, this is the volume, this is all of the water that this could hold. If we were thinking about this like a fish tank, this is how much water could be held inside of this cube. Okay, all right, cool. So that is for a square prism. So what about this shape? Okay, what kind of prism would this be? So hopefully you can see that at the top, it's a little less clear for the bottom, but we would assume it's the same for the bottom. For the top, we have a rectangle, okay? So since the formula for a rectangle is the same thing as a square, I'm going to just go ahead and use the exact same formula. So the volume is going to be equal to the length times the width times height. Perfect. So again, I just take all three of these numbers, 14, 6, and 10, and I multiply all of those together. Okay. So 14 times 6 times 10, and I get 840 inches cubed. Okay. So that's pretty straightforward for a square or a rectangular prism. Super easy. I just take all three of those numbers and multiply them together. For a triangle, it's going to be a little bit different. So now the formula I'm going to be using, since I have a triangle for my base, let's see, I have this triangle here, is the exact same formula, but now I'll have 1/2 times length times width. So let's go ahead and change this part here in our formula. So now I'm going to replace this base. The area of the base is a triangle, so now I'll replace that with 1/2 times length times width. Okay, so now this is the formula I would be using. So volume is going to be 1/2 times length times width times height. Okay, so really all that means now is I'm still going to take all three of these numbers that I've been using, just like all these other problems. I'll take all three of those numbers, length, width, and height, multiply them together, and then I'll also have to multiply that by 1/2, okay? Because it's kind of weird, but think about it like this. If I had this rectangular prism and I sliced it in half, okay, like let's say I sliced it in half this way, and I made a cut like that, that would make this triangular prism, okay? So if we took any of these, sliced it in half, that's how we get a triangular prism. So let's go ahead and do that. So 1/2 times length times width times height. Just multiply all three of those numbers together. Make sure we have that 1/2 there as well. So 3 times 4 times 2, get 24. Divide that in half, and I get 12 centimeters cubed. Awesome. Okay, so that would be your setup to find the volume of squares, rectangles, and triangular prisms. We're going to take a last little look at some word problems now. So let's go ahead and go over to those. and test out our knowledge, okay? So this word problem and any word problems that you run into in this unit, it's going to be super helpful if you draw a picture as you're reading. Okay, so as soon as they mention what kind of shape you're working with, I would be drawing that shape and then looking at any pieces of information they give you and then trying to see if you can label that onto your picture. And we've been practicing doing that where we take different numbers and we label that onto a picture, we put that onto a diagram. So that's what we're going to be trying to do here, except we need to draw whatever that picture is. So a cylinder, stop, okay? So I'm going to stop right there and just draw a cylinder because it mentions that. I know I'm going to use it somehow. So it doesn't have to be anything pretty, but if you can draw just like a rough picture of a cylinder to help you out for this, okay? So we have a cylinder and it's being used to collect water from a river. The cylinder has a diameter, okay? And I'm going to stop here. This is a math word, right? What is a diameter? So hopefully you recall a diameter. It goes from one side of our circle, our bases. It goes from one side to the other, but it has to go right through the center. So the diameter is 23 inches, okay? So see how I haven't even read through the whole thing, and I'm already starting to draw stuff down. So the diameter, it's 23 inches. That's automatically labeled onto my diagram, okay? Then it has a height, okay? So this is another math word. It has a height, so this prism starts there, stops, that's the height, and it's 16 inches, okay? What is the exact volume? Okay, I'll box that because that is the question I want to answer here. I really want to focus on figuring this out. What is the exact volume? And then more specifically, what is the volume rounded to the nearest tenth? Okay, I can do this. So I know that the formula for the volume of any prism is just volume equals base times height. And then I remember that for this B here, I need to plug in the area of the base, okay? So the base that I'm working with here, what shape is that, okay? So hopefully you see that the shape for the base is a circle. So then I need to remember, okay, what's the area of a circle? And that gets plugged in there. And we can cheat a little bit if we need to and go back to those formulas that we wrote down. So since we're dealing with a circle, that would be this formula. So this is now what I'm going to plug in for B. The area of the base is pi times radius squared. So let's go back over here. And in for this, I'm going to plug in pi times radius squared. So that is all of this here. I replaced B with this, and then this will just be multiplied by the height, okay? Awesome, so I have a formula that I can work with. Now, let's go over here and see from these numbers, what can I plug in to the formula? So my volume is going to be equal to pi. Remember, we changed pi to 3.14. And then we need to multiply this by the radius. Okay, because remember, R stands for the radius. Now, if I look at this picture, I don't have the radius right away. All I have is, remember, this is the diameter, okay? So if I have the diameter, how do I get the radius, okay? Remember, the radius is just half of the diameter, okay? So if I just take 23, divide that in half, so let me take 23 and divide that by 2, I get 11.5. So 11.5 is the radius here. Okay, and then make sure that is squared, so 11.5 squared, and then that is going to be multiplied by the height, which we just found was 16. So I have all my numbers plugged in. There's pi, that's the radius, which was half of the diameter, and then I'm multiplying that by the height. And all I have to do is just probably the easiest thing is to plug all of this into Desmos so you can avoid making any tiny little mistakes on this. But what I'm getting is 6,644.24. And since I'm rounding to the nearest tenth, that means I want one number after the decimal place, so this is just going to be 6,644.2 inches cubed. And that's how much space this little river water collecting container could hold. That's how much water it could hold. All right, we'll do one more problem. Here we go. So now this says a slab of concrete is being poured. I'm going to stop right there. A slab of concrete. Okay, a slab of concrete. What kind of shape is that in? Okay, well, a slab of concrete, typically we see that in like a square or a rectangle, right? It doesn't matter which one of those it is, because I know for a square and a rectangle, it's going to be using the same formula. But let's go ahead and draw some kind of picture here. So we have some kind of slab of concrete. This looks something like that. And it's being poured. So the slab is 2 inches wide, okay? So it doesn't matter if you put it on this side or this side, so we could just say 2 inches wide, 3 inches long, and 10 inches high. And this picture is definitely not to scale because it's a lot taller, so this should be drawn a lot taller than this, but that's okay. It serves the purpose. So that's the width, the length, and the height. What is the volume? Okay. Well, this is pretty easy because I know that for a rectangular prism, remember we just have to take all three of those numbers and multiply them together. Since our formula is this, the volume equals the base times the height. Remember the B stands for the area of the base. Okay. And since I know my base is a rectangle, it looks like, because it's 2 by 3, then I'm just going to be using this formula, which is length times width times height. I just take all three numbers and multiply those together. Okay, so 2 times 3 times 10 gives me 60. Done. So 60 inches cubed, that is the amount of concrete that is going to go inside of this slab.